Bene. Bene, siamo pronti a iniziare.
All right, so good morning and we are ready to start. So good morning, everyone. Good morning, ladies and gentlemen. This panel is entitled Tracking the Blue, and it deals with changes and challenges for the marine ecosystems. And the seas and the oceans have and play a fundamental role to support life on our planet, and in particular now with the challenges presented by the anthropic impact on the ecosystems, as well as on the oceans and the marine ecosystems. So we have some distinguished panelists, Professor Marco Faimali, and then Vincenzo Artale, Salvatrice Vizzini, Daniela, Silvia, and I will introduce each one of them just before they take the floor. And I would like to now give the floor to Marco Faimali, and he has been dealing with applied research in the framework of natural and anthropic risks, and also he particularly devotes himself to the study of materials and technologies and the interaction they have with the marine environment, as well as the monitoring activities able to highlight the effects of anthropic and technological effects on the marine system. And so at this point, I would like to ask, good morning, I'd like to ask you to please set the framework for the issue relating to the impacts and also in this new era of Anthropocene. Well, I need to be standing because I'm not able to speak by sitting. And even at a time when I'm on the phone, I have to go around and walk. I have some slides that can probably be useful, and let us put aside who I am. And I work at the INGV, so public research. So the institute which I'm managing is a new one, but it plays a main role when it comes to the anthropic impacts and sustainability. So I like to start from here, from this image. So that is where we live. But it's a blue sphere, and we call it planet Earth. So this is an anthropocentric vision, because the aliens that are, for instance, looking for the Earth, well, they see it and they wonder, well, why is it called Earth and not water? And 2/3 of our planet is covered by water, and also 71% of the Earth's surface is covered by water, 97.5% is salty water, seawater, and also in the globes of the past, well, the sea was something flat and blue, but this is not the case, because the sea, the ocean, is the largest ecosystem of the universe that is known so far. 2/3 of the planet, and average depth of 4,000 meters. So this is the ignored territory. So the blue part of our globe is ignored. So 1,330 million of cubic kilometers. And this is just to give you some data, because it's important to identify when we say that, well, this is an important, well, the oceans, of course, represent the main thermostat of our planet. And without the oceans, we would have 36 degrees more, and which would not allow the easy survival. And also, the oceans are the large blue lung of the planet. Let's breathe. Okay. For the first one, we thank plants. For the second one, we thank the blue forest of the sea. That is to say, we have weeds that produce 50% of the oxygen, and they also absorb the CO2 we are bringing. And it's to say they absorb 30%. And also, oceans are an important tank of biodiversity because 80% of living species are at the sea. And this is a frontier which is still unknown. So man decided to go to the moon, but paradoxically, it has not yet, let's say, put its feet on at the 4,000 meters of depth at the seabeds. But clearly enough, and you understood it on the basis of what we do within my institute, the ocean is also fragile lung, which is impacted by most of our activities in an aware or aware way. But I like to remind you that what we have outside is the Mare Nostrum, the Mediterranean, but I give you the three magic numbers. Out of the surface of world oceans, it's just 1%, the Mediterranean, but it contains 8% of world biodiversity, which is kept at the Mediterranean Sea, and it has a financial value. So the marine GDP is 20%. So why do I say that it's ignored? Because we have a treasure that provides us with all of these items, and it might be an important capital that must be recognized as an economic value. And also reasoning on the Anthropocene. Why am I saying this? Because we all come from this new era, and I'm like to show, well, because which one do you think represents us best? I mean, we are in harmony, or are we talking about a vertical relationship in which we as human beings want to be at the tip of the pyramid? So the planet conveyed to us an important sign with COVID, and COVID wanted to say that something which is small, little, not even a cell in terms of width, has, put us on our knees. So very often, well, if there's a problem relationship between man and the environment, and I'm just referring to a Nobel Prize, because if you want to understand a problem, you have to see it from far in order to understand it fully. So if we, let's say, put together the history of our planet in 24 hours, well, the story of human beings is the last 2 milliseconds. And in these 2 milliseconds, we made so huge damage. We caused such a big wreck and damage to our planet. There we are, as a little dot. So let's consider it as the spaceship, 8 billion passengers on it. And now we are living a new era, and I don't want to steal too much time to the other speakers, but Anthropocene. It means that so far, well, we have realized, well, or better, an era is starting where the human activities are really impacting on the natural changes in our planet. So we have recognized that our way of speeding up, and we see it immediately, speeding up some of our activities in a no-natural way. Well, of course, this is entailing consequences. That's easy to understand. So these are parameters, socioeconomic parameters, the right ones, and environmental parameters, the other ones. If you look far from a distance, you see that they all have a trend that at a certain point has a peak. If we look at the details, we see that both the socioeconomic trends, 1950, we had this beginning of this growth that was called the Great Acceleration. And this is the Anthropocene, where we started to alter our situation, and the same goes for the environmental trends. Here we might talk about that for hours, but what is, and I tell you actually very basically, the 7 signs that our species have left on the planet in the 2 milliseconds of our history. or better, well, 2 milliseconds is when the Homo sapiens appeared, but the Anthropocene is last 70 years. And in the 2 milliseconds, I would not be able to calculate how much it is. But what is the main impact here? Men had left on the planet some alarming situations.
Oh, vedi che ci siete arrivati, sì. Questo è il primo grande impatto.
This is the first main impact on the planet. The first bomb. So personally, I considered 16th of June 1945, the Manhattan Project in a desert in New Mexico. There was the explosion of the first bomb, the gift. That was the name. Because, of course, those that have studied and produced it thought that it would be, and it could be something positive and important and revolutionary. Then everything depends on the use we make of it, but like plastic. And of course, fossil fuels. Or the geological footprint. We never think about it, but over 50% of the Earth has been manipulated and altered. It's as if every day we, for instance, take home 27 kilograms of Earth. And the fertilization, the fertilizers. So, of course, we have drugged the system because we have to eat. I'm not judging anyone here. I'm just telling you what happened. I'm telling you the evident effects. We are living on the planet. Then the global warming, and of course, this is quite recognized. And also the chemical pollution. Every year, over 2,000 new molecules are produced. And very often we don't know the effect they will have. But fortunately, in the last few years, some laws have changed. And then the new materials which are becoming really emerging pollution, and plastic is one of them. Then I don't want to speak too long, and of course I want to leave the floor to the colleagues here. I don't know whether you prefer me to go ahead with these materials. Okay, I'll go back to the impacts. So if you look at it, well, plastic until the pre-pandemic era was enemy number one of the planet. Then after the pandemic, you probably realize that without plastic, things would be different. And that's now a sort of the terror for plastic has almost disappeared in the last 12 months. And I called it the plastic marine litter, the alien artificial species in the Mediterranean. And here we have some examples of species, and you see their names. And for instance, and I've joked that it's the Plasticosus shrimp, etc. Only 3% of plastic produced worldwide ends up in the sea. We may say, well, it's not that much after all, right? But it's not that much, as we said before. It depends, because every year we are talking about that number in terms of weight of plastic. And also, when you show these images, when you see these images, we think about countries like India or China. No, that's a global pollution, and maybe the plastic comes from China or India. But these are images of Italian beaches, and we made a campaign with Greenpeace, and it's near Sarno at the Gulf of Naples. This is just to say that it's not a matter of, we don't have to underestimate this. And also in the deep sea, we are finding, for instance, huge quantities of plastic. And what does plastic do at the sea? Well, macroplastic, the visible one, thanks to chemical and physical and biological actions, is degraded into smaller and smaller pieces. So from visible size, it becomes smaller and smaller up to microplastics with a size of around 1 millimeter. And then also according to the type of polymers and location, then it becomes nanoplastic. And what do we do then? As it happens with the research institutions working with us, we try to meet some of the demands and try to answer to these questions. That is saying microplastics, how many, where are they, how long they stay, what are made of, where they come from, are they becoming part of the trophic chain, what are they effects, what can we do, are they interacting with the other contaminants or pollutants? But since I don't have too much time, I'll just skip a few things. You say how we collect, etc. But I'd like to show to you some figures. This is a campaign made 2 years ago, and the red dots are, of course, the quantity of microplastic found in the different seas, where the red ones were clearly impacted, where there's a harbor and a city, but the green ones are the protected marine areas. But as you may see, the number of dots is not linked to, for instance, a protected. I mean, it doesn't matter where the water was taken in a city or in a protected area, because the results are more or less the same. The concentration of pieces of microplastic, well, that is almost the same. This means that the pollution is global. So what are the effects? Well, there are several European projects, but in 7 to 8 years of research, we, with all of the research groups that have been involved, because research cannot be done alone, and you do that in teams, of course.
Allora, chiaramente, macroplastiche, lo sapete, sono quelle che...
And, of course, there are microplastics that can choke turtles and may cause huge damage to animals. But I started to... Then, first of all, this has become microplastic. So clearly, microplastic can be swallowed by animals or eaten by animals. And if their size is microns, then of course they enter and exit. So let's say that they are not remaining. They're remaining for the time being, there's no evidence that they enter the tissues that we eat when it comes to fishes. But then, of course, if they enter and exit, they can become sort of Troy horses. That is, they can pollute, dissolve pollutants and release also in their organism. And also, we have the challenge for the future, nanoplastics. So now it's difficult to quantify them or monitor them or see them, but they can they go through the cellular membrane? Are we eating them? Are we going to find it out in 15 days when it's in 15, years when it's too late? We'll see. That's all. That's all. And I think it's enough for me. I don't want to steal too much time to my colleagues. Oh, no, just a final thing. For all this, please bear in mind that this is our responsibility. And we need to go back and behave as a species and to turn our behavior into a sort of circular, let's say, approach. So from the pyramid to the circle. Now, I think it's important to talk about another item of great interest for the oceans and the seas. That is the issue of climate change. And I would like to give the floor to Vincenzo Artale, an expert in climate and oceans, who was also the director of the energy shaping unit of ENEA. and he has an outstanding experience in this sector. I'd like to ask him what is the role and what are the processes that play a role in terms of global and warming, and also this is changing fast.
Approfitto di stare in piedi pure io. Ho preparato poche slide.
I have prepared a few slides. They are a bit dense, but it's to introduce the concept of climate change before we move on to talking about its functioning. And so I'm going to explain now how the ocean works. And we've heard so much about the impacts of the way in which we deal with our environment, the close environment. And so let us begin by saying that the ocean is the main component of the climate system, which is a complex system. So you imagine that the climate system has always been like this, in a balance, that it changes with the seasons, but it is a system which is always subjected to different forces. It's never in balance. It tries to look for a balance, but what is the problem? Imagine like a bowl inside a cup. If the rim of the cup is high, even though I try to move this bowl, it will remain in the cup, but it moves about constantly. But there is a point of attraction, which is the central point of this mug, let's say. And that means that statistical distribution allows us to have more or less the same temperature. There is a temperature, mean temperature of 15 degrees, and at least in the past 10,000 years, this value has always remained the same, except for great changes that took place in the Middle Ages, the little glaciation that took place up until the 19th century. So per se, the system is in a system that is in a state that is not truly balanced, but on the long term, then there are also other factors that have been ice ages over relatively short period of time, which are different if we consider the human scale. But some situations have been caused by the greenhouse effect, which is a good thing, except that it is good as long as it doesn't reach certain levels, because we are moving from a mean temperature of 15 degrees to 16 and more. So this is a change that is normal, and that is also explained by physics, because it is part of the of this system. But another important thing to say when we speak about this paradigm, or well, this image of this mug, if the rim of this mug gets lower and we get like a dish, then there are big changes that start taking place. If this cup, this mug changes in terms of its shape, and if we consider the changes that take place also because of human intervention, well, the bowl may fall easily from this plate, which is no longer a mug. So if we look at statistical distribution, let's say in the case of a variable such as temperature, you will see that before it was Gaussian. Now the distribution is starting to flatten out, which means that the resistance of this system is more affected by events. So any state, let's say what in the past was an extreme event, now becomes a normal event, because this distribution has flattened. There is no main event. There are all sorts of events which, let's say, extreme events have passed from 5 to 8%. And there is this probability distribution function which becomes flatter. And what happens in 2003 occurs. And the events of 2022, the great heat, also took place in 2003. So in November, the mean temperature had changed, and statistical distribution had all of a sudden moved to the right hand part of the chart. And in January and February, the temperature went back more or less to normal, or to a situation of balance. But a system which is the system may not necessarily get back to normal if we increase certain variables excessively. Because this system is chaotic, it's not linear, it means that if I increase temperature by 1 degree, it doesn't mean that the system as a whole increases by 1 degree. If this increases 2 degrees, then there are a series of other phenomena which become triggered. And the ocean is one of the leading elements in our system. Now, I have used this slide to explain that these processes cannot be studied in a lab. They are too complicated. And also in terms of spatial distribution, they cannot be reproduced in a lab. So our lab is a numerical model which experiments on all these factors. But this numerical system is not just a numerical simulation of very complex equations, but it is a hierarchy of models whereby it is very robust because it goes from qualitative to quantitative one. So the data observed are collected and processed for the future. And of course, there are adjustments that are constantly made also through observation. Because, as the previous speaker said, there is a part which is unknown in the ocean that we do not know at all. The data that we have referred to the first 700, 1,000 meters of the ocean. All the part of the abyss is unknown, and also the various measurements that we receive through buoys and sensors. There are sensors that go up to minus 2,000 meters, actually ignore all the rest. We have a network which monitors the abyss of the ocean, which is very interesting, and it's also a reserve of heat. So to demonstrate what I said, we have here a slide on simulation that allow us to quantify the effects of anthropic activities, particularly in terms of the effect of the CO2 which is introduced. This is a numerical experiment, and it's what our lab developed. These are not observations. Or I could say that to the left, we have the last 2,000 years with this reconstruction. Of course, this data has not been observed because we only have data for the last 70 years. The rest has been reconstructed indirectly through ice carrots or through tree barks. So we also base ourselves on archaeological data. All these things are put together, and we managed to reconstruct the trend. I'm not talking about the geological part, but anyway, so we have the last period in which farming has been developed, all the things that were explained before, and we see that there is a period in the Middle Ages marked by a small glaciation. Or to the left is all sorts of observation or information derived. And over just a few years, what happens is something that did not occur in the past 10,000 years. And there was this huge acceleration in the rise of temperature. temperature anomalies. This is the mean value. Whenever we process data, we speak about anomaly vis-a-vis a long mean temperature. So 1850, 1900s, and then versus this baseline, I will identify anomalies. So I'm talking about anomalies versus an average. To the right, we have another chart in which we have eliminated some things and we have introduced the anthropic effect. So in black to the right, you see the observations, so simulated so we are validating this model through this data. If I do not introduce CO2, there is a huge difference in blue. There is no comparison between the observed and the simulated data. So the simulated data coincides, except that if we also include many factors, including eruptions in the past few years, which cause a reduction in temperature for 2 or 3 years. So if we include all this, you see that there is an overlap only in certain conditions. So the numerical experiment validates what we assume, in other words, that there is an anthropic effect which has accelerated the temperature increase on the Earth. So this is evident and it's unquestionable. So this concerns the entire Earth. But if we look specifically at the ocean and if we look at details, the most important thing that was already highlighted by the previous speaker, even though it's a bit difficult to explain, is that the ocean and the Earth, we are the main element here is represented by the sun. So the sun can be good, but it can also be bad because so if you go to the beach, you can burn your skin, but the ozone in the atmosphere allows us to be less affected by the sun's rays. So O3 reduces the radiation that ultraviolet light that could damage our skin. So the ocean almost behaves as a dark body in the sense that it sort of absorbs all and does not release. So the ocean absorbs all radiation and it emits it in terms of warmth. When you go to the beach, you lay in the sun and you get tan. If you stand in front of a chimney, if you are standing before, I don't know, a fire, you don't get a tan. So the infrared warms up. And it's a bit like when you see a great cathedral, you will see that even though the cathedral is in the sun, the entrance is dark. Or if you throw a ball inside a cathedral, and you use them as an indication of temperature, they will move when they are warmed up. So even if there are some radiations that are absorbed, let's say by buildings. If you want to look into a house, you will not see inside, but only the outside is lit up. Anyway, this cycle is very complex, but if this system becomes unbalanced, of course, it's a problem. This is the main circulation on the ocean, and that is a result of the fact that the Earth is inclined. The poles are colder, the equator, the temperature is different, and the equator always gets the same type of light. So it's very hot at the equator, whereas at the poles it is much colder. And the ocean and the atmosphere together manage to reconstruct this thermal balance, which is like also something that is related to density, the difference in the weight of the Earth. So there is this ocean circulations that you see there, the Gulf Stream, etc. All the system is very delicate. It's very sensitive, and you realize that if, for instance, let's speak about the sea currents. If there are perturbations, the Gulf Stream, if there are problems with the Gulf Stream, of course, this will affect Northern Europe. And now we know that there is a 4-degree difference in terms of temperature in the countries where there is no Gulf Stream. So this system is related to convective processes. Here we see a slide that explains this. To the left, we see how the transition from a stable to an unstable system happens. The two cups that we were speaking about today, the two mugs, they oscillate, but they're still at the while. If from the mug we get to a normal plate that you see at the top, the system becomes unstable and the entire system becomes unbalanced. What we see for the future, and you see that to the right, which is the Anthropocene, we have a system which goes from stable to unstable. After a transitory period, we will get to a time when the temperature will be much higher and the climate will completely change. So after this, these transitions, I can't get into the details, we come to have a system which is completely different, and the extension of the Anthropocene, unless we try to put a brake to this rise in CO2 and other anthropic factors that have an impact on this change and that cause it, we will find ourselves with a system that will reach a balance, but it's not the balance that we want. For instance, it will be very difficult to have the life on this planet as we know it today. What is likely? You see that if the Gulf Stream to the left becomes weaker, there is a thermohaline circulation which is much less efficient, and a cooling down of the poles, a concentration of heat in the equatorial part of the world, which would have a very strong impact also on the Mediterranean, which reproduces this situation. This is one of the features of the future if we the Anthropocene continues to impact on the climate. Thank you, Vincenzo Artale. So great problems in terms of the increase of sea temperatures, and not just that, because there are also many other effects. And Titti Vizzini is going to speak about it. She is professor of ecology at the University of Palermo, and her research studies are focused on studying the ecology of marine coastal ecosystems. So she deals with the effects of climate change on organic matter, the effects of acidification, and non-eutrophic interactions among species. So in addition to the problem related to the warming up of waters, what are the other effects of climate change on the sea? First of all, good morning. We are now going to speak about other issues that concerns our seas and oceans, including the acidification of the oceans, which is another problem caused by CO2, because the origin is always related to the introduction of greenhouse effect and CO2 in the atmosphere. So we've seen before how the oceans absorb heat and also CO2. Some 30% of CO2 is introduced in the atmosphere and it is absorbed by the oceans. So they mitigate climate change and they reduce the negative effects of climate change. But the CO2, which is absorbed by the oceans, then has effects on the functioning of the oceans themselves, because CO2 is related to the acidic and neutral pH. So CO2 acts as a weak acid, which reduces marine pH. And when pH is reduced, one of the first effects is that the oceans, to a certain extent, manage to buffer, to limit this change and reduce the effect of CO2 by destroying carbonates to ensure that pH doesn't change vis-a-vis the initial values. But what does this imply if carbonates are destroyed? If they are present in the sediments as fragments, these components are lost by the system, and where carbonates are present in the organisms, for instance, in external structures of some organisms, think about shells or corals or algae, well, these organisms are affected by a number of problems. They are affected by stress, which is caused by this change in these external structures which protect the organism living inside the shell, the algae, or the corals. So, in addition to the problem of ocean acidification, there is also this loss of organisms which are called which have this external calcium carbonate structure. So how do calcifying organisms, how do we study this phenomena? Well, mainly they were studied in the lab, and so the conditions of acidification were reconstructed in a lab to check the effects on organisms. But this type of experimentations have limits because they expose an organism in a situation like an aquarium, which is different from the natural environment. There are not other species, there are no other factors that have an impact. And some 15 years ago, some natural systems were discovered, and also the INGV works on these systems as well, which are some naturally acidified areas in below the sea surface, where owing to volcanic activity, there are some gases which are introduced, including a lot of CO2, that is responsible for locally reducing the pH measurements. So we have a short video here, and these areas are like labs for us researchers in a sense, because it's as if we had huge aquarium in a natural environment, allowing us to understand what happens to the organisms that are exposed to a slightly lower pH degree level. So this is in Panarea. This is an island in Sicily, and you can see that there are these bubbles of gas, there are fluids that are issued, and that caused pH to be reduced. So what do we see in these environments? For instance, we see that some species, such as some shells or mollusks, the external part of their shell has been altered owing to precisely exposure to a lower pH level value. Here we have got examples of another experiment that was carried out by introducing some tiles in these naturally acidified areas, seeing what would happen over time to colonization. So what organisms would start living on these tiles, and we see that the scenarios are very different. We have here a tile that is exposed to a site with a very low pH, and it wasn't really colonized. There are very few species on top of it. versus some other conditions in which pH was either normal, what we expected, or at least slightly lower. So the first result is quite evident. pH, changes in pH reduce biodiversity, a topic which is also going to be addressed by other speakers. So biodiversity implies the presence of very different species, complex systems, and it is at the root of all those services and opportunities which the oceans provide us with, and that were also described by Professor Faimali earlier. So these labs are very important for us to study the effects of acidification, which, however, are not only recorded on individual species, so the carbonatic species, but also on processes which are a bit more complex in terms of the entire ecosystem. As we seen in these environments, is that whenever there is a situation of acidification or reduction of pH degrees, there are also differences in the relationships among beings, who eats who, and it was seen that there is an abundance of some types of fishes, such as the salp that eats a lot of algae, of seaweeds, and this causes variation in other species, such as sea urchins, whose diet changes and who start eating other species. So why is it important to study all these aspects? Well, because they are related to the way in which an ecosystem works. So if we start changing its functioning, then also some other features will change, making it more vulnerable also to other impacts. And we speak here about multiple stressors. The more a system is weakened by some sort of alteration, in this case acidification, the more it is going to be vulnerable to other types of impacts that can also impact the same site, let's say pollution or a rise in temperature. And what happens is that these systems become more simpler, with less species, less biodiversity, and less resistance to other changes. So there is an impoverishment of the potential of an ecosystem. In this sense, though, we should say that there are also some marine ecosystems and habitats that seem to be a bit less vulnerable vis-a-vis this type of alteration and disturbance. And amongst them, I would like to mention some unique and important marine systems, which are the so-called vegetal systems that are full of marine plants, such as our Posidonia oceanica. We all know, we're all familiar with this plant, which is endemic in the Mediterranean, and it only lives in the Mediterranean, and which creates very important habitats for biodiversity. Because they also offer us many other services, and they protect us from erosion, well, erosion of the coastlines. But within the framework of their relationship with the marine CO2 and acidification, Posidonia uses CO2 because it is at the root of photosynthesis. So the Posidonia absorbs CO2 from the water, and it plays a part in reducing the effects of acidification. And in addition, the Posidonia is amongst the most important systems that have been declared by the UNEP, the Environmental Program of the United Nations, as blue carbon systems, because it is a plant that can actually transform CO2 into biomass in its leaves and tissues, and to transfer a great part of this carbon, which comes from CO2, to the sediments, within the sediments, where it becomes accumulated for very long periods of time. So it is a sequester of CO2. It takes it from the column of water, and it transfers it into sediments. It is also something that allows us to fight against climate change, because it's a sequester. So all marine plants and the plants of coastal areas are not very widespread in terms of the surface occupied, because they only exist along the coast. But over the millennia, they sequestered great amounts of carbon, fighting against climate change. And so their role is the same as what you will find in forests with the trees, of course. It's the same function, let's say. But imagine what may happen if plants are removed, destroyed. These sediments very quickly give back all the substances that organisms have absorbed for millennia, and through dating of the structures formed by plants through carbon-14, we can come to the conclusion that some of the prairies that surround our coasts have also an age, well, they are 5,000 years old. So imagine how much carbon they have absorbed and accumulated. Destroying this prairie means that over just a few years, all this carbon that was absorbed over millennia will be given back, which is what happens during a fire during a fire on land, of course. So undoubtedly, we have to move towards processes that focus on these ecosystems.
Tanti altri ecosistemi marini sono sistemi che hanno.
As it happens with other ecosystems, there are some global estimates that say that 30% of, for instance, the green areas were lost in the last years, but in 1950s or with a particular year, but that was the moment in which a pathway started that led to an alteration of the marine environment. So 30% of these systems was lost. So think about how, in the meantime, also this important action to mitigate climate change was lost as well. At this point, it is fundamental to wonder one thing, that is, so what can we do? What is it being done? And also, I like to refer to a few points. They said to reduce the anthropic pressure. And in particular, there are policies that are being carried out at an international or European level. First one is a marine strategy, that is to say, EU provision that imposes some goals that mainly relate to the conditions of our seas. And also, there are several descriptors or analyses where all of the EU countries are committed. Another European directive in 2014 related to the maritime planning. It is, we have to think about the sea as a common territory that gives opportunity and resources, where variations are carried out in a coordinated and careful way by planning them to avoid conflicts. And also, it is important to plan in order to counter the degradation of our seas. Secondly, conservation, to increase the efforts to protect the marine ecosystems. And in this case as well, activities are being carried out with the so-called 30-30 paradigm. That is to say, to achieve 30% of marine and protected areas by 2030. So this is an ambitious goal, also because in this moment,
nazionale italiano, circa il 20%.
At the national level, nearly 20% of the land areas and 10% of the sea areas are subject to constraints. So this is a very ambitious goal, but it focuses on the attention to be paid to protection and conservation of the maritime ecosystems. Another thing is the Deep Sea Treaty that was signed by the UN a few months ago after 20 years of debate. And this means that all of the UN countries commit themselves to protect the deep sea. The deep sea is anything that goes beyond 200 miles from the coastlines. And this accounts for 60% of the oceans and nearly 50% of the global surface of our planet. So up to a while ago, there was no one's sea, whereas now it has to be protected. Last, it is important to carry out recovery interventions. And this is another important item where UN are somehow intervening because the degraded environments have to be recovered by means of a number of technologies. And when it comes to Posidonia, a lot of activities are being carried out at the Mediterranean level to reforest the sea, the Mediterranean Sea, with these plans, with positive effects on the biodiversity, but also other, let's say, side effects, such as the carbon capture. So with a tool that allows to intervene, for instance, in a positive way for our lives and well-being. So thank you so much for your attention. Thank you. Thank you so much, Titi. And now I would like to give the floor to Marco Oliverio, who's a professor of the University of La Sapienza, Rome, and he also deals with patterns and the dynamics of biodiversity in marine ecosystems. And I'd like to ask him, for instance, among the alien species and extinction, what can we reasonably expect as regards the biodiversity of the Mediterranean in the short and medium term? Well, first of all, what can we expect? Well, in order to make these forecasts, it is necessary to gather knowledge. I work at the level of the basic research.
Appunto, tutti piccoli tasselli che poi permettono di costruire modelli previsionali e cose di questo tipo. È un po' come, dicevo l'altro giorno, è un po' come acquistare.
So it's like, for instance, collecting the knowledge of a vocabulary or a dictionary. That is to say, you put together the knowledge of a dictionary, but no one would consider to write a book with a vocabulary of 120 words. Of course, you need to, let's say, gather knowledge and then know most of the dictionary. So to us, knowing the basic knowledge is fundamental to write books that tell about the models related to biodiversity for the future. But this is something we are lagging behind from the point of view of the activities we need to carry out. So it will take a while. For instance, are we able to say now on our planet how many species of living organisms exist? Are we able to say how many of them are in the Mediterranean or in Italy, or how many plants or animals or microbes? We are not able to. If you ask, for instance, a chemical expert how many elements are there, well, that was done from the beginning, because chemical experts did an inventory of with the periodical table. But they did that even before those elements were discovered either in nature or constructed in a laboratory. So even before discovering them, they were known already, whereas we are at a level that is far. So we have, let's say, considered there are a couple of million organisms for the time being. We have discovered them and given them a name, and we know where they are. And how many of them do we really have? Because every year we discover new ones, and I'll show you a chart that involves some groups of animals. Well, we estimate, and this is difficult, And it's like making, well, a sort of survey relating to political parties. Let's say, okay, more or less it's that one, there's a bracket between here and there. But this is a prudential approach. Let's say 10 million, okay. So in nearly 2 centuries and a half, we made an inventory of biodiversity of a couple of millions, and we did 1/5 of the work that had to be done. So we need to do 4/5 still. Well, how long will it take? Huge amount of time, of course. So more than 1,000 years will be needed. But in the meantime, most of these species will probably have, most of them disappeared, even before we discovered them. Differently from the chemical elements that have always been here, will always be here. So this is interesting to consider. And it has to increase our level of responsibility because we don't have so much time, and we cannot just, be on the safe side and say, okay, we have time. So on this topic in particular, I'm a zoologist and I'm dealing with animals, but Italy as a country, how's it? It's not bad, generally speaking, and it's not been traditionally bad. In 1995, that means a lot of time ago, in 1995, Italy produced a list of animal species known in its territory, which may seem quite silly, but think that in that moment, Italy was the first country in the world to do something like that. We had people at universities and research centers and museums that were able to know so well, for instance, the Italian wildlife, to make a list of the species known at that time. And we were the first country in the world before the US, before UK, before France or Germany or Australia or Switzerland or whatever. That were the countries that followed us, that is to say, in the mid-90s and 2000. But we were the first ones, and we need to be particularly proud of it. And I'm telling so because the numbers we're mentioning are the ones you see here. We estimated in 1995 nearly 55,000 animals, including the territorial waters, so hence marine animals. And then you see the numbers on the right-hand side. So this is an estimate that was updated already subsequently, and nearly 9,600 animals, maritime animals. What we know is that every year new species are discovered. And when we find out something that is huge, then it's in newspapers. But the daily practice of the specialists is to go around and discover that there are a lot of organisms like plants and microbes and animals that have not yet been given a name and a surname. And in fact, if you look at this, as from the beginning of the modern inventory of biodiversity in 1758, you see how curves are constantly increasing. There's just one group that has straight stability, birds. Because birds are a rather well-known group, and we've described, I won't say anything, but most of birds are known. Whereas all of the other groups, and you see, for instance, the other ones which are still increasing, and the trend is still increasing, and we'll have a lot of time ahead before it is fully completed. So we started with a coordination group that I'm part of, and which is the scientific committee for the Italian fauna. And we have a set of specialists both in Italy and outside of Italy to try and do again a national checklist. So the main goal is to understand whether in this decade we have passed from the previous checklist, how much knowledge we've gathered, and also to come to the detail of how much this knowledge can be useful to understand how this set of organisms react to the changes we're faced with. So this is our national territory, but then I'll tell you one thing in particular. There is to say the ones you see here, that is to say shellfishes, and you see here, well, this activity that I go back to previous slide because an important aspect that needs to be considered. Because this activity was coordinated by a series of people that work in the universities and museums, but with the participation of the so-called citizen science, that is to say, with the active involvement of people that in life do something else. They are pharmacists or they work for the post office, but they have a passion maybe for natural things, and they have data at their disposal. They have observation-based data. They observe, they collect shells, or they have underwater pictures. So they can share their knowledge in an integrated way. And of course, if guided scientifically, this becomes a huge heritage because, of course, we have tens and tens or hundreds of or thousands of people that may provide data. Therefore, the data of academia becomes a little as compared to the large mass of data that can come from the community and when the population is actively involved. And the works were very interesting from this point of view. I will not linger into the details, but I'd like to show you that compared to 1995, there was a 17% increase in the known species, and the vast majority of this increase is given by species that were not known at that time, so described dense discoveries for the science. But please remember the importance of the Italian fauna, and in particular, the Italian malacofauna accounts for nearly 70% of the fauna in the Mediterranean. So we are geographically located in a strategic way at the center and from the top to the bottom. So we tell a lot of stories which are absolutely incredible in our country. And also we represent a lot of components of the Mediterranean biodiversity. And of course, the Mediterranean is a hotspot of biodiversity with a particular history and peculiar characteristics where biodiversity, the biodiversity contained in our sea, is higher than what we would expect with an average linked to geographical areas. So far more than we might have. So it's an important sea from this point of view. So the knowledge relating to our fauna, the Italian one, becomes crucial and strategic when it comes to the knowledge of the Mediterranean. And also, let's come to the negative items, because among the species that we have and that we are including in our inventory, there's a percent of species which are so-called aliens. This is one of the topics dealing with changes and the changes we are going through, because the Anthropocene and the classification of this sector and also with our specific human, let's say, the human contribution is something that, of course, involves spreading.
Spesso alcune di queste epoche geologiche sono state caratterizzate e guidate da cambiamenti.
So this was characterized by changes that had to do with organisms. So the plants that are there and explode on the planet and make it possible to have habitats full of oxygen or carbon dioxide where animals can live. So the living organisms have participated very often in the timeline. And now this is becoming heavy on the entire planet, and it deserves, it's not a positive thing, but anyway, we are talking about the name of the geographical and era. But this is not something we have to be proud of, but we have to think about it, because a single species can have this type of impact. And there are alien species that have nothing to do with our fauna, but they come from elsewhere. Of course, they come from other locations, exotic locations, tropical ones from the other side of the world, and from the Caribbean area or Western Africa. And we find them in our seas and in our lands. And also, this is very much alarming. And in essence, it always has a little amount of exceptions, and it's always caused by us as humans. And it's not an enrichment of our biodiversity, because if we have alien species, well, this is not a good thing. Instead of saying, oh, we have more species and the biodiversity increases, well, actually, this is a problem. So if we have 2% of species, and of course, we are now developing it, and we've started the revision of the checklist, and we are halfway. But with a half of the revision made, we can make an estimation. So the complex of the Italian species will be around 64,000 from 55,000, the known ones, and we made a good increase of knowledge of our fauna, and the marine ones will exceed 10,000. So we estimate that will reach 10,900 or 11,000 species. And unfortunately, a small portion, which is however too big to forget, it's going to be alien species. But the alien species in general that we estimated, as we see, account for 2%, but see, they're always higher in terms of percentage. So the sea is a place where the phenomenon of alien species is particularly felt. And if you can see that well, starting at the sea, there's a study, for instance, the sea, it's even more complicated, because one thing is to go and study anything from geology to physics and chemistry and biology on the ground, and one thing is to do that underwater. So the underwater studies are more complicated and more expensive, and it takes longer for them to be completed. So this can also be considered as a prudential estimation, because we may have more species at the sea, and then we see that this phenomenon is widespread, and probably this is true. It's not an artifact, probably it's true. And however, this is a problem, and I'll show some of them to you. These are squids that were observed and that are now, which have been seen at the Greek Isles, but they're predators. They eat small fishes, so they have an impact on, for instance, the community of fishes we have. And also there are a lot of organisms that we, for instance, the oysters you see at the right-hand side, and they are typical, for instance, of the Levante Basin, but they are also extending towards our coasts. And most of these organisms are exceptions, less exceptions, and they come from the Red Sea and through the Suez area, and they are Lessepian migrators. And this is devoted to the Baron of Lesseps, that was the director of the works of, for instance, the cutting of the Suez Canal, and he also went to Panama, as he was so good at that. But the Lessepian migrants come to the Mediterranean, and of course they replace the organisms that build a part of the habitat in our sea, and this is leading to the disappearance of species. So you can imagine the damages in place. And I skip this, and I'll show the other one, and it has to do with the Italian coasts. And a colleague, Giulia Furfaro, has shown this curious observation, because these three organisms live together in Western Africa, like Ghana, Mauritania. And here, within the bryozone, there's another animal that eats it, or better, it eats some of the organisms that live close to it. So what you see on the left-hand side at the bottom, this is a C, where it eats the eggs of what is above. But these three species, which are connected among one another, well, one of them was found close to the Liguria area, because the bryozone, okay, and we can accept this, and then well, The other one, of course, okay, can be accepted, the nudibranch. And then there's also the nudibranch that eats the eggs. They've come together. They were found all together, probably brought maybe by vessels or transported randomly. And now they are being scattered close to the French coast. And it's very interesting because this tells a story, because these organisms very often are organisms that come from warm areas, the warm areas from our planet. So they come to us, and up to a while ago, they were in the Eastern Mediterranean. But now the Mediterranean is undergoing the effects of the global warming, and there's a homogenization in terms of temperatures of the sea. So for this reason, these species have the possibility to get the right habitat, and also the problem is that this causes problems to some of our species that prefer to be in cold water. So this is what happens, but at a certain point, the sea that is becoming warmer now, and sometimes half a degree is sufficient to have a temperature for an organism in order to allow eggs or to be suitable in its biology. And this is what is happening. What do we need? We have incomplete knowledge because we are good at doing these inventories, and yet there's still a lot to do with the 1/5 of our activity. And of course, we estimate that the Mediterranean accounts for 40% of the knowledge, which is not that much, actually, because it's still 60% has to be achieved. But this knowledge is broadly incomplete. If we look at the interesting aspects, let us say how each of these species behaves when it comes to acidification or temperature increase. Do we know what the effects are? Well, for instance, the nudibranch, if the temperature increases by half a degree, what happens to it? And if the acidification increases and the pH is lowered by 0.1, what happens to it? We don't know. We don't know. And the vast majority of organisms, well, we don't know what they eat, how long they live, and when they go through reproduction. What they eat, how long they live, and when they reproduce themselves. We know these things just for 2% of what we know, which in turn is a fraction of what actually lives in our seas. So we need huge investments and on basic knowledge. Things are changing, and things are changing in a fast way. And even our knowledge needs to speed up, because the speed we're having now, well, we will not be able to keep up with changes, and we are lacking in infrastructural investments, and we need to be convinced that this type of research is important, and this is another thing that we need to convince our policymakers, both in Italy and abroad, that is, basic knowledge is fundamental, but because without basic knowledge, which is our dictionary, we will not be able to write any book, and the events that are taking place will be something that we just realize after.
Thank you. Thank you very much, Marco. And now the last speaker for our panel, Daniela Silvia Pace. She's a researcher for the environmental department of the Sapienza University. She deals with acoustic ecology and the preservation of marine mammals and animals. So climate change also has an impact on a less known aspect of marine biodiversity, that's the acoustic level. What is the effect of this on marine habitats? Good morning to everyone. I'm getting up as well. I can't be sitting for too long. I'm going to speak about a topic which is almost unknown for most people. So the fact that the sea is a place full of sounds, full of atmospheres, and the sound is used by so many organisms to do all sorts of things, including communicating. So now I'm speaking to you, and you can hear me because our ear is developed precisely to listen to our mutual voices, but it doesn't mean that we all speak in the same way. I will speak about what happens in the ocean. You remember 1953, Jacques Cousteau's book is published, The Silent World. So we have been growing up with this idea of silence, that's dumb as a fish. This is what we say in Italian. But this is not the case remotely. And in fact, we can say that our marine world is actually full of sounds. Sounds that we can categorize as follows: the sounds which come from atmospheric events, thunders, raining, or earthquakes that multiply and make you listen to the sounds, the sound of waves, for instance. There is an earthquake which has a sound too. This is the sound of an earthquake underwater. Then the so-called anthropophonies. So we are in the Anthropocene, and everything that is caused by human beings. Human beings produce a lot of sounds, which then eventually are made inside the ocean, the sea. All these sonars with which are used to, well, for the boats and the vessels, for them to move without hitting anything hidden. This is the sound of the sound of a boat's propeller. And then there are animals which emit sounds. We've seen from Professor Oliverio that there are 11,000 species, and we don't know much of them, but what we know is that some 1,500 of them produce sounds in the marine environment. And this is not a small number, but that's only because our knowledge is very limited still. So we do not know how many species actually emit sounds. So let us listen to marine mammals, whales, sperm whales. Let us listen to their sounds. So a sperm whale issues these sounds, make these sounds that some people during the Second World War thought that this was somebody hitting something. They didn't know that this was made by a sperm whale. Let us now listen to the sound of whales. They sound like mooing. It's very low frequency sounds. Now the sperm whale, let's start it again. Let us listen to shrimps, the sound of shrimps. Shrimps here. And imagine that the choir of all these shrimps, which on our coasts belong to specific families, can actually have an impact on the instruments used by submarines. So they are among the strongest sounds that can actually act as a disturbance, or they can be so strong as to be used by shrimps as a gun, because there is a shrimp that uses these sounds to sort of shoot and therefore knock out some smaller shrimps that they prey on. Let us now listen to dolphins, our friends. Well, we are familiar with their sounds. Let us listen to the sound of fishes. So these are the sounds with the which a fish emits. So it's not true that when we get underwater, it's so silent. It's quite the reverse. Imagine, as it happens, all these sounds were made together. But there's a problem here because we go here in a different direction, because these are human-made sounds and they interfere in this system. And we heard this from Professor Vizzini, how all the elements of the ecosystem interact with each other. And these interactions are ensured by communication and the way in which organisms exchange information. So when we start making excessively strong noises or too intense ones, we alter completely the system and communication mechanisms by marine organisms. Let us listen to the sound now, for instance. So these are true explosions. These are systems through air guns, through which the bottom of the sea is explored to find gas and oil. So these systems are used for looking for oil and gas. It's a bit invasive, of course, because it is used for prospecting purposes. Of course, we mustn't condemn necessarily this way in which the ocean is also studied, because it's not just a system for prospecting, but it also allows us to know the bottom of the ocean, well, the ocean floor, but we must find a way of living together. And we all live in this planet, so we have to make sure that human activities do not cause too much damage. We have to find a way of managing in a better way the ocean and the seas. So how do we study our marine animals? Well, we place some instruments on the sea bottom, and what we do is we place microphones, hydrophones they are called, which are placed in the water. They are permanently placed somewhere on some occasions, or else we make acoustic measurements, we analyze the data, and we obtain, in fact, data concerning all these sounds emitted by animals, geophonies, and anthropophonies. So geophonies, it's non-biological ambient sounds generated by the natural world. And what we get, it's these charts that look complex, but they're not, because these are the representations of an acoustic landscape. So through the analysis of our sounds, we can isolate biological components. Here, for instance, we see the fish component. This is a representation. This is time, and these are the frequencies at which these sounds are made. So we manage to put together or to break down our landscape depending on its components, so fishes, a whale, or a passing vessel, a ship, and all these elements tell us how the soundscape, this is what it's called, is a dynamic element that we can study, and we can also study biodiversity. So how are these sounds made? For instance, in fishes, there are some muscles that have an impact on some organs, such as the swimming bladder, or mollusks use their claws, producing the strong sounds that we heard. See, there is this movement. Or in marine mammals, there are some very complex structures that somehow manage to produce vibrations. So they don't have vocal cords, but somehow allowing the air to pass through specific anatomic features allows them to produce these sounds. So what are these sounds for marine organisms? Well, they are used to explore the environment. For instance, in an environment where solar radiation is only reaches up to a certain point, all the rest is black and blue, the sound becomes like the eyes with which these organisms can see, navigate, explore, and move about this environment, which is not flat. The sea bottom is full of canyons and mountains, so there have to be some highways, let's say, to travel. And many organisms manage to find them precisely by resorting to acoustics, courting and reproduction. For instance, the males of humpback whales actually create songs. They make acoustic compositions, and they can express their territorial features. For instance, a fish starts making these sounds to protect its home or for aggression, in the case of crabs, or advertise their services, in the sense that there are some crabs which clean up other organisms, and through their acoustic sounds, they manage to make themselves available, and they signal this to other organisms, or guidance and orientation. And this refers to what the previous speaker said, in the sense that all these systems are connected. Guide and orientation. Titi spoke about the coral reef systems, all these organisms which have got carbonaceous skeletons. If you have been snorkeling on a reef barrier, you might have felt just this, activity underwater, because, for instance, these sounds give orientation to fishes' larvae. So fishes choose acoustic signals to find a place where to grow or to live. These are the explorations I was telling you about, and these are the continuing sounds. So everything that is produced by mankind through sea trade and traveling. The problem is that the frequencies overlap with those of marine animals. So the frequency of these sounds produced by human beings overlap with those of animals. It's like there is a terrible sound, there's an overlap. There is like a pneumatic hammer when you walk on a street and there is all this surrounding noise, and the type of damage that animals can suffer because of this sound caused by human beings can lead to the death of some organisms, or there may be permanent or transitory damage. Think that when you go to a disco, you will hear muffled sound for a while after you go out. So these mechanisms cause your hearing to be lost for just a limited period of time. It may happen also to organisms in the sea. Another aspect related to sound is that up until today, we never thought about what could be the impact on the entire ecosystem. So why do we all, because we always thought about great marine mammals, the cetaceans, everybody knows them. So there is also this aspect that helps us in communicating about the importance of sound in the sea. But in a study conducted in 2017, it was discovered through a study that anthropogenic sound has an impact on marine species, and they may also be killed by the wrong sounds, let's say. But why is sound so important, and why it is also related to climate change? Well, because in underwater, and that's why so many marine species also have evolved the ability to produce sounds themselves or using them, is that water is an excellent means of transmission of sound. So sound travels in water 5 times faster than in air. We are speaking about 1,500 meters per second versus 350 meters per second in the air. So it's very fast, and therefore it is very important to be able to communicate at this speed. But also acidification, and therefore the presence of CO2, in some way increases this speed. And so here we put together 2 different problems. On the one hand, water is warmer, so the speed of transmission of sound is faster. Acidification increases, so the transmission of sound is even faster, but species have not evolved for this speed. And the ears, let's say, or the way in which the different organisms used to perceive sound are not adapted to this speed. So they had 500 million years before they evolved some structures or organs that are used for communication and to carry out all the functions we spoke about. So the problem of time and acceleration, the acceleration of phenomena, etc., is something that also involves the topic of sound transmission. So this is the acidification that you were told about by other speakers. And I just wanted to show you that when we go and study, when we study sound, it may sound something so small or a niche type of studies, but it isn't, because in fact we can monitor the changes which take place at the level of biodiversity, and also study our soundscapes. If these soundscapes are devoid of crustaceans or fishes, and then they become impoverished, they become inappropriate for the survival of many species. There are so many phenomena that can be studied. Unfortunately, we don't have much time, but we do this basically by using technology. So we can position all our instruments and inside the sea, in the sea, and we will use some platforms or devices that are equipped with sensors that can actually be fitted on these structures. So what is being done? Well, finally, sound or noise has been identified as a pollutant. So think about acoustic pollution, think about human beings, how human beings are affected by terrible noises, think about heart diseases, stress. Well, these are all phenomena that we also find in the marine environment. So finally, sound and noise, certain sounds of noise have been recognized as pollution. So in the already mentioned marine strategy, one of the indicators of the good health of the sea is precisely represented by noise. And there is this indicator which must be 11, the value must be 11. So increasingly in research, we are studying this phenomena to try and understand what is actually the threshold, the comfort threshold for sound that we have to ensure to the different species. And we're trying to improve the biology of acoustic disturbance, because the problems caused by noise are not just, I shoot, you break my ear and I die. Well, there are sublethal effects that are the most difficult somehow to study, because if an area is noisy and I reproduce there and I must move somewhere else because I can't stay there anymore because of the noise, then the partner who should come there and with which I should reproduce, well, we're not going to be able to meet anymore as fishes. For instance, the singing humpback whale that attracts female with complex songs. If all this is blurred by anthropic noise, then they will not reproduce. So the effects of the noise can be also looked at on a longer scale, longer time scale. And biological processes will probably have changed because of this. I would like to conclude by thanking some of the people who are here, all the students with whom we work, all the people that we work with. There are some people with CNR with whom we have been cooperating. So the entire team of statisticians who work with us. And I thank you all for your attention. Thank you. Thank you, Daniela Pace. And I would like to just make a round of questions. You spoke about the Anthropocene, Marco. Could we have a smart, in inverted commas, Anthropocene? Well, it is necessary, really. And we have increasingly been hearing about artificial intelligence. Well, perhaps we should start by supporting natural intelligence. And I think that the investment is precisely what Marco was referring to. In other words, an investment in knowledge. So science, basic knowledge, technologies, but applied not just to, extract things from the planet, but to support it. And then we also have to make a cultural investment. So if you want to survive to the Anthropocene, is what I said at the end of my presentation. First of all, we must start acting as a species, being aware that if we behave as individuals, who cares? I will be dead anyway. but this is no longer the approach, the behavior adopted by a species. So being a member of the species was the worst, perhaps, or the strongest, or the one at the apex of the pyramid. But this is risky if I look at it as a species. Of course, if we address things as individuals, things will be very different, and we must act as species by also investing on science, on knowledge. We must look at the place where we live as our common home for our species to be able to survive. Vincenzo Artale, you spoke about the issue of the absorption of CO2, absorption of CO2. So up until when can the oceans solve problems by absorbing most CO2? And is it true that in some cases the absorption capacity of the oceans is becoming reduced? Well, the answer is what has been illustrated by all the different presentations. The warmer it gets, the less CO2 it absorbs. So we're talking about seawater. There is a problem which is quite underestimated, but which is really coming to the forefront, and that is of stratification. One of the main aspects identified by the IPCC report, there is a very interesting also a very interesting article on Nature on the impact of stratification or layering, and which says that somehow layering or stratification is essential. Imagine it as some weights that you use to go underwater, to go scuba diving. So if there is a great evaporation, there are some mechanisms that make it possible to transport oxygen and nutrients to the surface. But if there is an excessive stratification, there is too much potential energy, then I will not have a physical system capable of subtracting water and accumulating the energy, potential transformation of energy, turning it into kinetic energy. So one aspect is temperature, which of course reduces the capacity to absorb substances. So it becomes more gaseous, it becomes trapped, and under specific physical conditions it's less transformed. Sorry, the speaker is not speaking in close enough to the microphone, as well as illustrating mechanisms that are related to temperature and the column of water. So stratification has an impact on the water's ability to remix, which is essential to feed the entire biochemical dynamics. So one of the feedbacks that can be started, negative feedbacks that can be started by climate change, well, stratification is considered among the main impacts that are being felt. So the effect of global warming is that all the heat is trapped into the top strata. I will not delve any more on these topics because my colleagues are better at me at doing this, and but the answer is yes. So there are many negative impacts that have been caused. So from a scientific perspective, the situation is a mess. Professor Vizzini, so you were speaking about the effects of acidification, but can we actually get to the hypothesis that in the future coral reefs and mollusks and such organisms will disappear, or they will become very frail and fragile and even more exposed to risk factors? Well, we are working on models a lot today, as also Professor Artale was saying earlier, and there are some projections which at 2010 are quite alarming, because they speak about a reduction in pH by 0.304 units versus the pre-industrial period or era. So these are small variations, But no, they are actually alarming because pH is examined on a logarithmic scale. So 0.1 difference means that the cause of acidification, so the H plus ion that acidifies water, has increased also by 30%, by almost 30%, sorry. So the problem is very significant, and future scenarios speak about, well, illustrate a high level of vulnerability for calcifying species if variations were to continue at the speed that we have been recording over this period of time. And then undoubtedly, we should also consider the oceanic system as a system where you cannot separate the different components and also the different pressures. As Professor Artale was saying earlier, there is a problem also in terms of the combination of all these issues with temperature that could have an impact on some effects in a positive way, in the sense of reducing some effects of climate change. So we truly have to consider that it's very difficult to make forecasts. And I don't even like to sound alarmist, but it's important to monitor and to study and to get to better know these phenomena. And we must commit ourselves at the global level to reducing CO2 emissions. So this is essential. And as Marco Oliverio was saying, we need more research. So, by the way, since you talked about the fact that you have been monitoring the environment and found more species, but could it be that the ocean's resilience is higher than we think? So some way they managed to react positively to climate change. You participated in a campaign in the Sea of Ross, this great Antarctic seas. Do they perhaps have resilience abilities, or can they respond to human impacts in a better way than we would imagine? Well, this is a problem. This is a question that is quite straightforward in terms of the answer. And the answer is yes or no. Well, yes, in a sense, we may say that ecosystems on this planet have the ability to adapt, also because they cannot do anything else. So any system, if you change some parameters, the system will adapt. It adapts, but it means that some components become are replaced by other components, and they face extinction, of course. So some components will be replaced. If we look at our planet, let's say 100 years from now, based on the trends of temperature and acidification that we have, well, this planet will still be here, undoubtedly. Life will not have become extinct, sorry. The oceans will still be there. But the problem is, the question is, are we still going to be there? Because we're one of the species on this planet, one of them. So we have progressed, evolved, adapting ourselves to the situation through our biological features, but under certain conditions. So when we change the system so drastically and the system reacts accordingly and responds, we don't like to read the environment's answers, but the system is going to change. It's going to adapt. It's going to suffer from our perspective, replacing and eliminating some elements. But the problem is that it is likely that if we go on this way, we are going to come to extinction ourselves. So that's very likely. So what I'm going to tell people whenever I teach during biology or ecology courses, or when I participate in talks with the rest of the world, well, we have a very selfish and opportunistic interest in understanding these kind of things, problems, and taking measures, because the planet will go on regardless of us. It has been doing this for millions of years. So the fractions of seconds that correspond to human presence on this planet is irrelevant. Of course, we are very much interested in participate for a few more minutes in the life of this planet if we use this 24-hour scale. But to do that, we must understand these mechanisms and take measures. Otherwise, we're going to be left out. For Daniela Pace, what is the situation like in connection with the acoustic elements of our seas. We hear about electric cars on our roads, but could this have a positive effect on the sea? In other words, having ships, vessels which are electric, use electric engines.
È molto importante e molto interessante.
Lake data is very interesting and very important because most of the noise we see is caused by the vessels, but there are millions of vessels that move in this moment in the seas of the world. And this means movement of people, goods, economy of the sea. And of course, all the vessels were done with the ideas of the past. So the blades we saw there are, and the noise, the pervasive noise, which is so detrimental for animals, we should probably replace all of the blades and try and go towards this direction. And this is not easy, because all the problems would be solved by slowing down. But the concept of slowing down is not the slowing down in change, but it's the slowing down also by slowing down by a few knots, we might improve a series of things. But it's expensive, because if I have to go from point A to point B, it takes me 1 day, and then it takes me 1 day and a half. Well, this entails a change also in terms of organization of a port or a harbor, where you have a schedule of timelines and times. So the problem, as a matter of fact, the problem of noise might be easily solved. So think about it. The noise is here now. I'm silent. There's no noise any longer. There's no noise anymore. So it's as if we switch off the sources, we eliminate the problem of noise pollution. We cannot do that, unfortunately, but we have to intervene. For instance, when it comes to electric engines, it's possible to eliminate noise. And also we are relying on the engineers to deal with the cavitation of blades. And this is what happens. For instance, yes, it is feasible, but there's the need for a will to do that and the right investments. Okay, so we are coming to the end of this extraordinary initiative organized by the INGV, and hopefully it is going to continue next year as well. And the understanding of these phenomena by a broad audience is important in order to give research, also the right resources that are fundamental in order to fly, let's say. And because to do that, it's not just necessary to be willing to, but you also need resources.
Una donna che passeggiava sola e disperata sul bagnasciuga al tramonto.
Il destino la fece incontrare con un uomo solo e disperato, e anche lui passeggiava sul bagnasciuga al tramonto.
I loro passi si imprimevano sulla sabbia,
cancellati via via dall'inesorabilità delle onde.
Scusi? Ma che sta facendo con quel secchiello?
E lei che fa con quel forchettone?
No, guardi, non è un forchettone, è una pinza a raccogliere rifiuti.
E che ci fa? Complimenti per lo spirito di iniziativa.
Scusi? Guardi che è vietato raccogliere le conchiglie, Se proprio vuole raccogliere qualcosa, può aiutarmi con le cicche di sigaretta, qua è pieno.
Io non voglio raccogliere le cicche, che schifo. A me servono le conchiglie. No, e mia moglie si rilassa facendo decoupage.
Ah, decoupage.
Sì, mi vuole fare un posacenere perché butto le cicche nel giardino di sotto e quelli si sono lamentati con l'amministratore.
Ah, perché non gliene fa fare anche uno da portarsi in spiaggia?
Ma in spiaggia non servono, dai, le cicche le infilo direttamente nella sabbia. Cioè, ma volevo dire, poi le raccolgo, sì. Sì.
Quindi lei, per fare dei posaceneri di dubbio gusto, ruba la casa ai paguri.
A parte che io qua non vedo nessun paguro, cioè, queste sono conchiglie vuote, sono vuote, vedi? Cioè, poi scusa, a lei chi la conosce?
Io l'ho capita a lei, Lei è uno di quelli che occupa le case popolari a discapito di chi ne ha diritto, vero?
Ma lei che senta, allora, vada a raccogliere i rifiuti di là, io continuo a prendere le conchiglie di qua.
Ma non gliene frega niente dei paguri?
Sì, come no, guardi, sono la mia prima preoccupazione, i paguri, sì.
Guardi che i paguri non ci nascono mica con la conchiglia, sa? Loro se la vanno a cercare la conchiglia giusta e scelgono con cura la casa perfetta per le proprie esigenze, proprio come facciamo noi.
Se non la smette di seguirmi, chiamo i vigili, va bene?
Li chiami? Su, li chiami?
Sì,
Così le fanno la multa, Guardi che i paguri all'inizio prendono una conchiglia più piccola, ma poi quando le esigenze
Sì,
cambiano,
accendono un mutuo,
lasciano la casa vecchia per trasferirsi in una più grande.
con la stanza per i bambini.
Ma se lei mi fa lo speculatore immobiliare, lo sa che cosa succede?
Sì, cosa?
Succede che quelli la casa non se la possono più permettere.
E lei lo sa che cosa succede a me se torno a casa senza conchiglie? Succede che scatta il finimondo, scatta l'interrogatorio. Perché se uno dice alla moglie che ha già tradito con la scusa del corso di ceramica, moglie che l'ha scoperto e perdonato, però è ancora incazzata nera, ecco, se uno dice a questa moglie sul piede di guerra che va a prendere le conchiglie e poi uno dopo un'ora torna senza conchiglie, quella giustamente si imbufalisce visti i precedenti, non è che sta lì a ascoltare storie di paguri. Succede che mi butta fuori senza passare dal via e senza conchiglie, senza casa, non ci restano i paguri, ci resto io, va bene? No,
Lei lo sa che cos'è un ecosistema?
Allora,
No?
in questo momento io no.
Beh, un ecosistema è l'insieme degli esseri viventi e degli elementi non viventi che si organizzano, che collaborano in un ambiente, capisce? No. Le conchiglie fanno parte dell'ecosistema marino. I paguri le abitano. Gli uccelli le raccolgono per farsi il nido. I pesci ci si nascondono dai predatori. E i trattori pulisci spiaggia le fanno a pezzi per raccogliere le cicche di sigarette che buttate a lei e a sua moglie.
Non lo faremo più, giuro. Stiamo facendo i posaceneri apposta.
Ma non con le conchiglie, vero?
No,
Non con le conchiglie.
non con le conchiglie, giuro, non con le conchiglie, va via.
Guardi.
Che?
Guardi il mare. Bello,
Bellissimo.
Bello, romantico, Non c'è niente di più appagante che ascoltare il rumore delle onde direttamente dalla camera da letto della sua villetta abusiva, vero?
Ma lei come fa a conoscere tutto il mio patrimonio immobiliare, scusi?
Adesso facciamo una cosa, Perché non scrive un bel pensiero ai posteri, lo infila in una bella bottiglia di plastica e lo affida alle onde, i suoi ultimi pensieri prima di lasciare questo mondo.
Prima di lasciare questo... Allora io così su due piedi non lo so se riesco a trovare la frase giusta, ma poi alla fine uno che cos'è che potrebbe dire di veramente interessante ai posteri? Non lo so, lei che cosa sceglierebbe di raccontare di sé? Il suo impegno per l'ambiente, l'amore per le conchiglie?
Niente!
Niente.
Io non racconterei niente!
No.
Anche perché i pesci, ma non gliene può fregare di meno delle sue riflessioni sulla vita! Soprattutto perché lei non capisce che le sue azioni interferiscono con la vita!
Allora, io credo che lei mi stia dando un po' troppa importanza, va bene?
No. Lei si sta dando troppa importanza. Il mare non è una romantica distesa d'acqua instagrammabile a cui affidare i propri sogni. È il più grande ecosistema del nostro pianeta. C'è un mondo lì dentro, un mondo meraviglioso dove tutto è strettamente connesso, esattamente come sulla terraferma. È una bottiglia di plastica lasciata alle onde, per quanto con un profondissimo messaggio dentro. Monnezza è fuori dall'acqua e monnezza sarà anche dentro l'acqua. E lo stesso ragionamento vale per tutti quegli elementi come luce, temperatura, tutti elementi che modificano, che noi stiamo modificando. Li stiamo modificando con il nostro comportamento incentrato solo su noi stessi, come se la specie umana fosse il centro del mondo.
Però io stavo solo raccogliendo le conchiglie, non è che stavo oscurando il sole, ma non potrebbe lasciarmi andare. No, ma se guardi, le lo svuoto il secchiello, mi invento una scusa con mia moglie, va bene?
Più il mare si scalda, più io vedo gli alieni.
Capisco.
Pesci alieni.
Sì. Certo.
Lei lo sa cos'è un elemento alieno?
Allora, io ho visto il primo Men in Black, però sinceramente adesso così su due piedi...
Sono alghe, sono pesci, sono elementi marini che prima nel Mediterraneo non c'era. O almeno se c'erano non potevano riprodursi perché l'acqua era troppo fredda. Ma adesso che il Mediterraneo si è scaldato...
vengono qui a darci dentro, mica scemi sti pesci. Senta, però io ora andrei. Cioè, vista la questione conchiglie, sa com'è? Prima torno, meglio è.
Gli alieni si riproducono velocemente.
Beati loro.
Troppo velocemente. E diventano un rischio per l'intero ecosistema. Prenda la salpa.
Sì, certo, senta, la prendo, se mi dice dov'è gliela vado a prendere subito.
La salpa
salpa
è un pesce autoctono, ma adesso è molto difficile trovarla nel Mediterraneo. E lo sa di chi è la colpa?
Di certo non mia, io non l'ho proprio spostata la salpa.
Del pesce coniglio.
Ecco, vede, non c'ero proprio arrivato.
Il pesce coniglio è un pesce esotico, arrivato direttamente dal Mar Rosso, ha attraversato il canale di Suez. Quando è arrivato nel Mediterraneo si è guardato intorno e ha detto: bel temporino sto Mediterraneo, me ricordavo un po' più freddino. Quasi quasi mi trasferisco e metto su famiglia.
Ho capito. E la salpa ha detto, io con questi migranti non voglio avere niente a che fare, se vengono loro me ne vado io. Giusto?
Il pesce coniglio mangia le alghe, esattamente come la salpa, ma ha molta più fame. Tanta più fame da desertificare gli interi fondali in cui vive, da modificare l'intero ecosistema in cui abita. Luce, temperatura, pressione, salinità, motonnoso, maree, correnti. Cambia un fattore e le conseguenze per l'intero ecosistema sono imprevedibili, potenzialmente catastrofiche. Stiamo rischiando di perdere le specie tipiche del nostro Mediterraneo. E di chi sarebbe la colpa?
E di chi sarebbe?
Me lo dica lei.
Del pesce coniglio.
Basta, io mi ammazzo.
No,
basta. Cioè, uno di cui ce ne fosse uno che mi capisse. Uno che non si comportasse da idiota. No, basta. Io le provate tutte, io ho provato a sensibilizzare, a organizzare gruppi di polizia a spiaggia, ma niente. Sempre sola finisco, no, sempre sola. I turisti arrivano e dicono: Island, e io li raggiungo al porto, gli spiego tutto e loro dicono che they want to help to preserve the island, e poi io arrivo al porto, gli spiego tutto, ma poi spariscono, sono tutti a farsi selfie, le foto con lo sprizzino, il tonno appena pescato sulla barchetta, so pittoresco, a farsi le foto con le stelle marine che le fanno crepare invece di ributtarle subito in acqua.
Ho capito, però lei non può farsi carico dei mali del mondo, cioè lei deve reagire.
Le foto con le cape sante sulle sise.
Guardi, se me ne fa vedere una io le do la mia opinione, perché veramente...
Non gliene frega niente a nessuno dei paguri.
Ma non è vero, a me importa tantissimo dei paguri.
Davvero?
Davvero. Ma poi io a causa loro sto rischiando di perdere un sacco di mazzate da mia moglie, io sono proprio l'eroe dei paguri.
Ma gliene importa anche dell'ecosistema?
Sì, pure dell'ecosistema, ovvio, avanti, su, mi dia la pistola.
Ma lei ha capito davvero che cos'è un ecosistema?
Sì, è un po' come casa, giusto?
Giusto.
E niente è come casa. Io l'ho capito la prima volta che mi ha buttato fuori mia moglie, su, avanti, mi dia la pistola, su. Ma è acqua sporca.
Sì, è un po' colorato, ma non si preoccupi, si pulisce facilmente, non c'è neanche bisogno di strofinare.
Ma perché fa così?
Ma perché mica sono pazza, no? Faccio così, perché sennò voi non mi ascoltate, non mi ascolta nessuno. Questo è il dito, sta indicando la luna. Concentratevi sulla luna, cazzo.
Nadia Lobue e Massimo Chiappini, bravi, grazie.
Cogliamo giusto l'occasione per ringraziare tutta la grandissima organizzazione che che ci sta dietro questo evento. È il primo anno, anche noi speriamo che ce ne siano altri. Noi siamo la compagnia Carmentalia, ci occupiamo di nuova drammaturgia ed è stato un piacere collaborare, perché l'arte che incontra la scienza è un bellissimo matrimonio e speriamo insomma di frequentarlo più spesso. Grazie. Ovunque, ovunque, ovunque. Grazie.
Bene, grazie a tutti e al prossimo anno.